a factor?
X plus 2.
So for this example, that is a factor.
Yes.
So what is a factor? Use that as an example, but what is a factor?
Yes.
Would you like another example? What are factors of those?
2.
So what is a factor? 2 is a factor. Anything else?
1.
Anything else?
0.5.
-1.
X.
So the highest common factor would be?
2. X.
Very good. So what's a factor?
Something that can be divisible by both numbers.
Very good. And you just said a factor for this correctly. You said it was
1.
x plus 2. That's what you said, isn't it?
Yes.
Is that the what's left over when we do that?
3x. X plus 3.
Correct?
Yes.
So, you are correct, Lockie, when you say something we can divide two terms by. We use factorising obviously in a number of contexts, but when you know with quadratics, that's how we use them. How do we, well, let's go to the next question, we'll come back to that. What are roots of functions? What are roots of functions? What do you reckon, George? No idea. Remember when we graph on our calculator? It's my hint.
Is it like where they go down? Because roots are down.
Not a bad guess, but not quite.
Isn't it the x values?
It is the x values when what?
X equals 0.
X value, wouldn't that just be 0? X value when?
1.
What's another name for that? So it's an x in a sense, correct? So, with reference to this, what are our roots? So we know that equals, x plus 2, x plus 1. What are the roots of that function? X equals negative 2 and negative 1. So can we see a common relationship here between our factors and our roots of these functions when they're in a certain form? Can we see that? What was the pattern there?
Factors roots, or if you were take,
So it's just give me the negative of whatever our factor is, correct? Now that's in a quadratic example. We're going to try and look at it in a cubic example. So I want you to open your books to 3.3 and we're going to look at question 6. And question 6 says, consider the polynomial 2x to the power of 4 plus x to the power of 3 minus 4x squared take 5x plus 6. Thank you. Okay, that's our function. And we get told to identify whether the following are factors, and they give us A, x, B is x minus what? minus 1. C is x plus 3.
And x plus 1.
D is x plus 1. Now remember with our factors and our roots, if this factor is a root, I'll start with this one we have here, right? With our null factor law, what does x plus 2 got to equal? X plus 2 must equal 0, which means x must equal negative 2. In this scenario, what's x got to equal? X equals 0. We want x plus 1 to equal 0. What's x going to equal? Positive 1, correct? X plus 3 equals 0. What's x going to equal? And x plus 1 equals 0. X is going to equal? So to identify whether it's a factor or not, all we need to do is, like if I call this fx, is sum each of those values in. So for a, I would let x equal 0. 2 times 0 to the power of 4, 3, the 0 to the power of 3, what's going to be left behind? 6. So 0 plus 0 plus 0 plus 0 plus 6. Is that a factor?
No.
What should it equal?
0.
So as this does not equal 0, x is not a factor. Because remember, for these roots, for that to be a factor, it must have it equal 0. So let's try B. Let's see if B works. Just tilt that a little bit. So for B, what do we want x to equal? For B? Positive 1. X minus 1 must equal 0, therefore x must equal 1. So we're subbing our value, 2 times 1 to the power of 4 plus 1 to the power of 3 minus 4, 1 to the power of 2 minus 5, 1 plus 6. It's going to be 2 plus 1 minus 4 minus 5 plus 6. 3 minus 9 plus 6, 0. F1 equals 0. What does that mean? X minus 1 is a factor. What am I going to do now? What do you think I want you to do now? Have a go. What do you have to do for C? Let x equal negative 3, solve, see what it equals, correct? If it's anything but 0, is it a factor? If it is 0, we've got ourselves a factor. So we're going to do question 6 and question 7 in exercise 3.3.